Good morning. This is Jonah, Dr. Schulman. I'm starting to make these videos again. This is 2.1 frequency distribution. So, if you want to actually join, I'm doing them all through Zoom. So you're more than welcome to join me on these. We could figure these out together if you have questions, but I'll be doing them in the mornings. Uh, this one I'm doing in D1. The first set I did in D2, depending on your class. But if you want to come and watch, you could always shoot me an email. I'm doing them in the morning. So I'm going to share my screen. This is the first time we're doing some math. I'll be writing them all out. I can show you how to do it on Excel this time, and then I'll show you StatCrunch. I'm going to show you both ways for chapter two, but this is the first time we're going to do some numbers. So I hope you're excited. Sorry, this intro is a little weird, but here we go. Feel free to email me for questions. As usual, this will be in the announcements like everything else. So how to get to two, chapter 2.1, frequency distribution. So here is my screen. Um, this is the notes in case you're not sure where the notes are. Well, there's double introduction. That's okay though. So let's just go to intro. If you click this link, it'll bring you right to the notes. It's in the first announcement. And this is 1.1. I did all those 1.2, 1.3. I also made you a, what did I make? While I was heading back to New Mexico, I made another one, the review of chapter one. But this is chapter two. It's got a bunch of stuff 6, 7, 12, 18, 20, 25 on page 48. So I'll show you every way to do this by hand using computer. I don't think I'll use StatCrunch for this one, but I'll be using them all. If you want to look at the whole thing, you can click to the side, this little bookshelf thingy. And now this is what we're looking at. How do we get to the course? You go to My SFC, you click on the canvas, it'll open up. This is the video I'm making right now. You go to modules and you go to 2.1. And again, you could do the practice and all this other stuff. And this is an Excel file to work with. You want to use it. I guess I could use it to show you some frequency table stuff. So I'm going to download this guy. So I'm going to click download and work with it. I'm going to open the file. And I'll just show you some frequency table stuff right away before we jump into it as like a demo on Excel. Because why not? When it opens. Another way to get to Excel and stuff, if you want to work with it a different way, if it doesn't open up right away, let's say you have a Mac or something, you can click here. What did I click on? I clicked on the Microsoft 365. Sorry, things are a little movementy. That's okay. Just more people I added to the course. Welcome if you're new. There's a lot of people in here, which I think is great. More people want to join the class this week. Go for it. So what did I click? I clicked this thing, this one right here. This is just in case it doesn't work. My Excel opened here, but I'm actually going to open it in the web version in case you don't have in case you don't have it downloaded. So here it is. I must have clicked it twice. So I'm going to click, I'm not going to update it, but I'm going to enable editing so I can mess with it. And this will open in any sort of, God, on Mac, I'm trying to remember what it's called. This will open in Sheets. I'm pretty sure it's Sheets. So we have all this. And the first thing I'm going to do is just highlight the data, left click on it, copy it. Whoa, fancy. Or you can hit Control C, and then I'm going to click over here on the bottom left Excel, and I'm going to open it up. I'm just going to open a blank workbook, and I'm going to just show you some frequency table moves. I'll do them by hand. I'll show you what it means. I'm going to hit Control V. This is the way yours should look if you have the web version. On the downloaded version, shoot me an email. If you want to see this just on StatCrunch, honestly, it doesn't matter to me. I'll show you on whatever. So boom, ta-da, I've got everything. So what is frequency table? So Here, I'll have this on one side. And our fancy notes on the other. So what is a frequency table? Frequency tables. And here's our book. Okay, so this is just when they say frequency table, and I'll do some typing because I know my handwriting's been kind of gross. It means the ranges of numerical values. And this helps us out because it tells us like the amounts in each. A good way to really think about this, is it's just how many are in each group. You make the groups whatever you want, but basically it's just how many are in each group. And when they say relative, that means we got to do the percentage of each. Remember, when they say percentage, they just mean divided by. This word means divide by, and this word means 100. So the relative frequencies, it's not out of 100 though. So there's relative. It just means like the percent out of the group. So it's basically for relative frequencies, it's whatever we want to get over the total. What do I mean by that? It's the range of that group over n, and n just stands for the total amount. That's what that means. Okay. All right. And then besides relative percentage, they have cumulative. You can think about the word cumulative as accumulate. If I could spell, that'd be great. Accumulate. And it just means totals. We just have to add everything up. So it's like the little piece added to the total. Is that right? That doesn't look right, but it says it is. So you think about cumulative as the totals. It's a good way to start it. Those are like the words I'm talking about. So here's our table. Sex, males and females. That's all we got. Whatever these are, weight, SEP, WAT, BMISP. I don't know what all these are, but we can make a frequency table for one of them. So let's just pick one. The first thing I'm going to do is notice that each of these is linked, right? This male has a 72, a 59, a 22, and an 18.4, right? That's all of this dude's scores. But let's say I just care about this first column and I want it in order so I can see how low and high it goes, the minimum, the maximum, things like that. So the first thing I'm going to do is I'm going to sort this thing. So I'm going to go to oh, sorry. I'm going to go to this. I'm not commenting on it. I'm going to go to this. If you hover by the top, it drops. I'm going to go to this sort and filter. And I want to go ascending. That means smallest to biggest. Now it says expand your selection. Yes. Because each one of these is linked, I can't change this male to have a different one. I can't just change this column. So I actually have to, when all the data is linked, I have to expand and sort it. If I were to do this one, all my data is going to be messed up. I've got the wrong guy or girl with the wrong WSBAT. So here we go. I hit the button. We start at 42. Oh God, sorry for that terrible scroll. Don't look at how many tables I have. I'm building another course, and we go to 97. So this means I start at 42 and then go to 97. So we already have some information. My minimum, and I'll just make a little table just for data here. So our minimum, our smallest number, minimum's 42. Our maximum, and we're just doing this column for W. So we should say what this is. This is the data just broken down by WTSEP. Our max is 97. Our we could do our average or mean. This is their average. So if I want the mean or average, I can click the equal sign and then type in the word average. And I could do parentheses and I can type in from B2. I'll show you a few ways to do this. B2 all the way, see how that highlighted? All the way to B97. Sorry, I was getting a call. I hit enter. That's my mean. That's my average. Isn't that so nice? If I want the mode, this was the column I was talking about before. Mode is the most. This helped the Greeks win this Peloponnesian War. Thucydides was like, how can I make sure um we defend ourselves? So they counted how many bricks were around the building, and whatever one came out the most, or the mode, that was the one that they used to make their ladders to figure out how many bricks were in it, and they won the war. And that's why we have a lot of stuff. Our language, all Romance language, I don't care if it's Spanish, Italian, French, they all come from Greeks, and it's because they lasted so long, and mode was a part of it. Figuring out how many was the most. So here's another way to do mode. So equal mode, and this is in case there's multiple modes, and I'm just going to highlight all of them. I'm just going to click and drag. It's another way to do it. And then I'll show you a third way to find stuff. 64. So there's one mode. So 64 comes up the most times. There's a bunch of 56s, but 64, we have the most of them at 1, 2, 3, 4, 5, 6 64s. That one comes out the most. Let's say we want the median. Median stands for middle. It was created back in the day when they were making astrolabes and stuff, which is kind of cool. So it really figured out the when ships like prime meridian, median, they figured out the middle route to get to it. So they're looking for the middle. So if I do equals, and I type in median, I put parentheses, I'm just going to put B2 colon to B, what is it, 68? 68. It basically is telling us that we have 67 of these things. Oops, sorry. There we go. Enter. The mean is also 64. That's cool that they match. So let's see another way to get this data. If I highlight it all, and I can show you how to do this on StatCrunch too. If I highlight it all, here, I just have to move this. Oops, I hit stop share. Sorry about that. Share the screen. Share the screen. I just have to move this thing so I can show you another move. It's going to be annoying. Just for now. Okay, so if I highlight this, just the numbers I want. On the bottom, it tells me how many 67. It gives me my average. It also gives me the sum. And the sum is usually a big E. It's a sigma. It's a weird E looking for sum. So you see it matches 65.059, 65.0597. The count is 67. We don't have that. So I'm going to put N is 67. And I'm going to put my sum. And here's another way to get sum. A third way to get sum is if you click equals on the bottom. Sorry. I just literally click under it and I go to, I think if I just type equals sum, it does it automatically. Oh no, that's if you want to do it the long way. I think if I just click the E symbol when I'm underneath that column, it just comes up real fast. So I can show you as many moves as I can. So if I click this more options, this one changes the numbers, especially if they get too big, you can change it. This is increase, decrease decimal, cells, auto sum. Perfect. It automatically does it. Oops. And I clicked a random button like a fool, so I gotta do it again. So if you just are here and we go here, we can literally just click auto sum and enter 4359. So 4359 is right there. Just give me 1 second. And there's the sum. Okay, so, but it's just some extra information. If you want quartiles, we'll get into it. I'll show you how to draw box plots and all that stuff. But the main thing we want to do is make a frequency table. So to make one, I'm just going to do range of WTSP. I know I'm going from 42 to 97, so I'll make a little range. And then we're going to just type in frequency, which is the amount of each. I'm going to do a relative frequency. I'll do a relative and I'll do a cumulative. And I'll show you how to do it on here. And then I'll show you by hand as we go through the ones. But I just thought this would be a good thing. Well, if I double click this, they'll be like perfect sizes. Isn't that cool? And boom. Now, because it's a table, I'm going to just make it look a little pretty. So I'm going to fill this in gray. And I'm also going to give it a nice little box around it. Ta-da. So now it looks like it. So the ranges for this WTSE. So I'm going to go from 40 to 49, 50 to 59. We just have to go up to 100. 60 to 69. Haha, funny number. 70 to 79. Those are whole numbers. I can just do it this way. 80 to 89. 90 to 99. And that's all we need. You know why? The highest one's 97. So the frequency is how many is in each. So I'm going to also give these a left box. Or you can do the whole thing right here. You can just finish the look of the table. Make it look all cool. Now I got to move this again. No, I don't. Okay, so here we go. We'll just do a round it this way. So there we go. Now it's kind of like a table. So the first one, how many are between 40 and 49? Remember, we want to be in this column. So from 40 to 49, there are 2. And look, it counts it on the bottom for you, right there at the very bottom. So we got 2. 50 to 59, there's a whole mess. There is 22 of them. And I might as well also show you how to make a histogram too. 60 through 69. We've got 23. I'm looking down here, so I'm not counting as high. There's 23. 70 through 79. I have 13. I can already tell the skew of this thing. We'll talk about skew too when we do the bar graphs. But I'll just do a little 80 through 89. There's only 3 of them. And then finally, and we know it has to equal 67, so that's how we can check ourselves, make sure we don't mess up. You should always check before you keep going. And 90 through 99, because we all make mistakes. 90 through 99, we've got 4. All right, so I'm just going to do equal sum. From here, colon, to here, and parenthesis, 67 and matches, we're good. Now the relative. So each one of these, I want to take it and divide by 67. So that's literally what I can do. So one way we can do that is we can do equals the 2 divided by, because it's just a big calculator. It gives us the value. Isn't that so nice? So we know it's 3%, 0.03. Another way, Excel does all these for you, so I don't have to do each of them by hand. 2 divided by 67, 22 divided by 67. So a way to do that is we click the equal sign. I click the first box, and I divide it by 67. Now, if I were to use this one, so it's in a column, it's going to mess everything up. Ta-da! So I did it right. I can drag it by, I go from a plus sign to a cross, and I drag down, ta-da, and if I do one more, guess what? It should give me 100 or 1. Now, let's say you want actual percentages instead of these weird numbers. You can highlight them all, go through these little circles, and we're just going to change the number format to a percentage. If you want to increase or decrease the decimal, let's say you don't like 2.99%. You can go decrease decimal, and we can do it one more time. I don't know if this looks nice for you, but there we go. 3, 2, and 1% is 100%. It's the total. So those are all of our relative. Now, cumulative is basically how much is in every preceding group. That's what that means. So I'll show you move to that. So the first one is just 2. And the next one is 22 plus 2. So we can do it like this, where it's like 2, and the next one's 22 plus 2. Oops. equal sign 22 plus 2, and it'll do it for you that way, but since we have Excel, it should help us out. So if I do equal sign, this box, enter. Now this one, I'm going to do equals this box plus this box. So the 2 plus the 22, and now I don't have to add. If I go all the way down, I should get 67. Oops, oh, well, I made a mistake. Guess what? We're all human. Oh, I think I have to do the top one before. So if you make a mistake, it's not a big deal. You hit undo. So I think this is a bad, okay, so I got it. So here we go. The first thing I'm gonna do is I'm just gonna type the number 2, or you can click this box. It's up to you. I'll click the box just for fun. Actually, let's work this way. The second one, I just have to do equal sign. I believe it is this one. No, it's got to be the preceding one, so it all adds. So it has to be this box plus this box. So in my case, it's M3 plus K4. Now, if I drag all these down, it should work. Oh, well, not the bottom, that's adding them all. See how the last one's 67 and it matches to here? This means everything preceding it will add up to 67. So we're good. I'll do that again. So I did the first box, which is equals 2, and then I just did, I can show you again. So it's equals this guy plus, oh, sorry. Well, either one it's adding, so it doesn't matter the order. Ta-da. And then I dragged it down, and we got all of our cumulative frequencies. One more thing I'll show you, and I know it's a lot before we get into the stuff, is I'll just show you how to make one. So if you want to make a histogram, what's a histogram? A histogram is just a bar graph where they're all kind of squished together. So all we need is our range and our frequency. If I highlight it, I got to move this. I'm just going to go here. I'm going to go to insert. Now, this is where it messes up a little bit. It doesn't mess this up on StatCrunch, but you click what's actually the column graph. I know it's so weird. You click the custom column. You don't click histogram. I don't know why, but here we go. Now, how to make this into histogram? Well, the first thing is it's not just a frequency. We can change our title. It's WTSEP, whatever that is. We shouldn't use an acronym, but I don't know where we got this from. So I'm just going to change that. And you're supposed to always label your axes. Oh, and you see a horizontal axis? If it's not a histogram unless they're touching. So if I get rid of the gap, we see it's all touching. We just turn on a title for this guy. And then I'm going to turn on a title for the vertical axis. And there's another way to do it too. You could always click this. Oh, if you have the other version, there's a plus sign here you turn them on. Or you just click these and it like opens. Either way. But in data labels is nice too. If I turn on data labels, it tells me exactly how much there's in each in case my eyes suck. I usually put the labels on the inside end, and all I'm going to do is fill it in white so we can see them. I like that, but you can get fancy with it if you like. We don't need a data table. What we do have to turn off is this legends business. So sometimes working on this one is just kind of weird. But we just have to turn off wherever it says legend because we don't need it. Because it's all one thing. And I'm also gonna turn on the vertical axis. You should always have, and you can change this too. See, that's out of 25, that might be misleading. You can make this out of 100 or 67, which is the total amount if you like. But then you can't really see most of the numbers, so maybe we'll make it out of 40. I don't know. Yeah, 0 to 40 is okay. It really depends on how you really want to see it. If you want to get it as close as possible, you can make it to 24. But I always like it starting at 0. So that's however the graph looks right to you. The only other thing I want to do is turn on the title. All right, and then we're just going to change the name to the title. So here's our histogram. You can like make it fancy by like messing with everything about it. You know, we can make this bold and underlined the colors and stuff, but it doesn't really matter. The only thing that really needs to matter is that we have the right names on it. So instead of title, I'm going to call this ranges. And I'm going to call this one amounts. That's all it is. And that's how you make a little histogram with it. I'll show you with the other one too, but here it is, nice and pretty next to the chart. All right, that was a ton of information. Let's get to the book questions. But that's how you make a frequency table. I'll do them by hand for this other one, but computer helps. Well, it depends how hard they are. So let's jump into it. So we go to modules where we are. And we've got 2.1, which is our book assignment. And we have 6, 7, 12, 18, 20, 25. So to get to the book, I go to MyMathLab and Mastering. And I'm just going to open the book. Maybe they give us some more information about frequency tables in here. I just know it's about frequency tables, so I thought I'd do a nice little demo about everything you possibly could need. We go to eText, and I like opening the whole book by clicking this little link. And we're just going to go to chapter 2. It's probably chapter 1 because that's what I was doing last. Oh no, it is chapter 2. All right, these are the questions. And we'll do the questions, but I just want to look in the book first and see if there's anything else that they went over that you might need. The number of original values, that's a pretty good definition. Partition into categories, I like it. Okay, so the upper limit is the highest part of that value. The lower limit is the smallest part of that value. That's cool. And we're just figuring out the range in between. These are the boundaries between them. I like that. The midpoint, the middle, the width is how big they are. So on the example I made, you can see, on the example I made, you could see that the lower one is 40, 50, 60. The upper ones are the 49, 50. And what's in the middle? Well, there are numbers between 49 and 50. 49.2, 49.3, all of that stuff I didn't put in. Why didn't I put them in? Because our questions were all in whole numbers. I would not have been able to do that for this one because it's got decimals. So I'd have to add those decimal plates. That's good information. So yeah, obviously you can read this. Caution. The width, the class width would be select the number of cases between 5 and 20. The number usually are affected by the convenience of using roads. The ideal number of classes for distribution can be approximated by 1 plus a log of n divided by log of 2, where n is the number of data values. We don't use this guideline in this book. Well, if you want to know what they mean by this, 1 plus log of n divided by log of 2, I can at least tell you, even though they're not everything that they won't show you, I guess I'll show you. They don't want to show it to you because it's hard. Like obviously, like working with logs can be tricky. So let me just get rid of that guy and let me pull up this book. I think it's right here. I'll always show you whatever they're kind of hiding for. Well, they're not hiding it from you, but so what do they mean? 1 plus log of n divided by log of 2. So this is what they're talking about. Ooh, that was ugly. My parentheses don't want to be parentheses, which is okay. I'm just trying to show that we have to do this part first, and I don't know why it's not letting me put a little parentheses. There we go. So what is log? And obviously you don't need it, so if you don't want to work with it, this is what, God, might as well show you what log looks like first. go in a graphing calculator just to show you what a log looks like. Log is just the opposite of an exponent. It's just to get rid of exponents. That's all it means. So log of x. There's the graph. This is what log looks like. Ta-da! Log of 0. Log of 1 is 0 or 1.05. I'll click it. No, log of 1 is 0. Log of 5 is 0.0699. So what does this mean? What does this weird picture mean? A log is just the opposite of an exponent. So let's say we have 3 squared. 3 squared, you just draw a square with 3. This means I have a square with side length 3. What is 3 times 3? 9. Ta-da. And normally to get rid of it, we would do get ready for this, a fancy square root. So if I have a box, I have a box of area 9. Right? What is one side of that square? So when they say the word square root, it means side of square. That's what this root means. So one side is a 3. That's how we get rid of exponents usually. However, what if we have like square root of 16? I'll do one more example. So here's a box of 16 squares, right? What does one side have to be? 4, because 4 times 4 gives you 16. But if we have a term that's like 4 to the x equals 16, right? And we want to get rid of the x. Now, we know that 16 is just 4 squared, right? We know it's going to be 4 squared equals 16. So we already know that's the 2, right? But how do we get rid of it? What if it's something weird? That's just where we have logs. This is where log comes in. So you put a log on the right, log of 4 equals log of 16. The x goes to the front. So x times log. The log allows us to move the exponents to the right. Equals log of 16. So sorry about that. That's ugly. It allows us to get rid of it. We divide both sides by log of 4. Those cancel. And look what happens when I put this in the calculator. So I'll put the calculator. I'm going to do log. Oh, I guess I have to write it first. So log of 16 divided by 4 log. I guess I have to write it first. So log of 16 divided by log of 4, I hit equals. And I have the 2. Oh my God, look, it matches. So we're left with x is 2. That's all logs do. They just get rid of exponents. I always think of them as like bays. So log of base. When there's not a base, it's just 10. So log base 4 of 2. Oh, sorry. And this is how you write it. So this is your base. That's your answer. That's your exponent. It's like your first girlfriend or boyfriend, your bay. Base answer exponent. So you just loop it and swoop it around. They can put the x wherever they want, but 4 squared, this is how you turn it to the other form. So 4 squared equals 16. Now we have all the pieces. Because they could put an x here, they could put an x here, they could put an x here. So what was the crazy equation they gave you? So it's log of n, so your total divided by log of 2, 1 plus that. So we can make an example. So 1 plus log, let's use the one that we had before. Our n is 67 divided by log of 2. And let's just see what it is. So I'm going to put the calculator, clear it. So I've got 67 log Okay, divided by 2 log is 6.066, and we add 1 to that. So it should be 7. So they're telling us that our range for this one should have been 7, which is fine. So what does that mean? They wanted each one of these widths, the width things, the difference between the two consecutive lower limits. So they think the best way for ours should have been ready. Our smallest number was 42. So we should have done 42 to 49, and then 50 to 50, 42, 43, 44, 45. Oh, sorry, 48. So always one less, my bad. 42 through 48, and then it should have been 49 through 50, 51, 52, 53, 56. It's always one less than you think because we're accounting for the smaller one, and then it's 57 through. Yeah, so this is the way they should have did it. We did ours by 10, which isn't the biggest deal, but they're saying it's ideal is this way. So that's the real math that they were hiding from you. So let's do their method for the width. Sorry, their method for the width is maximum number minus minimum number divided by the cases. So this is the way they want you to do it. I'm always going to show you, I guess, what they're hiding from you. So for the width, our maximum, it's max minus minimum divided by n. So let's check it out. If you want to use the log one, I don't mind. So our max was 97. Our min was 42. We're dividing it by 67. That'll give us the width. 97 minus 42. You always got to do the top first. So it's 55 divided by 67. See how off this is from the other one? They got 0.8. So their width is just supposed to be 0.8. And it's so different from the actual one, which I don't mind, but we can see that it should have been 7. And what did we get? We got 0.8. So that basically means each one of these things should just be 1 away from each other. So it's like 42, 43, oh, sorry, 42, 42.8, 42.8, plus 0.8, right? So it's basically just going to have decimals and be really small. We went by 10. Real way is to go by 7. Their, I guess, weird formula, which I'm not the biggest fan of, is just to go by 0.8 of a decimal each time. What can you do? It's what the book is trying to dumb down for you, but it happens. It happens. Okay. So using the table, 90 minus 5 divided by 7. Oh, and then you're supposed to round it to a more convenient number. So we got 0.8. What would I do if we're going to use their silly little method? I would go by ones every time. This symbol means approximate. So I would go by ones every time. So I would do 42 to 43. If we're going by ones every time, our chart would look like this. 42 to 42.9, 43 to 43.9, 44 to 44.9. And we'd have to go all the way down to 97. But as you can see, by using the real math, 7 would have made a lot better of a chart, or 10 would have been a better chart, but that's okay. Example 2. We did this, the percentage. So frequency for class, sum of all frequencies, We did this. So you get the percentages, which is nice. And then the cumulative, which you add them up. I assume that's what they were going to have you do. Oh, we get to do normal distribution. Cool. So normal distributions, this is what a normal distribution looks like. We're going to have a whole chapter on this, but the normal distribution is this beautiful looking bell curve. This is what's normal. Now, I'm going to do my best to explain what this means. It's usually symmetric. So I'm going to try my best to just show you what a symmetrical means about this. Oh, nice. I like it. Guess I could use the example, but I'm going to just make one up. We're going to use intelligence quotient IQ scores because 100's in the middle. I think that'll make sense. So here we go. I'll explain normal distribution and then we'll do the question. So here's now normal distribution. So this has the mean is in the middle. And I could show you so much here, but I'm not going to go too crazy. So we're just going to put 100 in the middle, and this is for IQ score. And let's say we have a standard deviation, how much we deviate from the means. This is our mean, our average. Our standard deviation, how far away are we? And when we actually start doing deviation, I will actually do the whole formula for you. This is what standard deviation is. Sorry. This is what standard deviation is for you. Cool, right? And I'll show you what this means. But basically, standard deviation is the sum of all the differences between each data point and the mean squared divided by n minus 1. Why do we have to square it? Because if we take every difference from our middle, we'll end up with 0. So in order to get an actual number, you have to square it. And to make it standardized, you take the square root. So 100's in the middle. I believe this is 32% each. I'm just going to double check the percentages. Whoa! Black screen of death. Yes, I'm doing too much on this little laptop. Let's just look at an image of it. Information. It is 34. 34, 14, 2. Got it. Okay, so what does this mean? So 34 and 34, I'm going to round. So this is +1 standard deviation, and this is -1 standard deviation. What does that mean? So this means 34 plus 34 is 60. I'll use a different color. This means that 68% of people fall between 1 standard deviation away from the mean. This means 68% of people fall between a 90 IQ and 110 IQ. And it works the same thing for like heights and weights and everything else. So then this is going to be another, this is 14%. And that's -2 standard deviations. And this one is 14%. And that's +2 standard deviations. So what's 14 plus 14? 28, right? And what is 28 plus 68? This means 96% of people fall between 80 IQ and 120 IQ. So you do have super smart people, but there's not a lot of them, right? You do have people who are slower, but not a lot of them. Most people, 96% of people are going to fall between an 80 score and 120 score. I don't really know exactly what the standard deviation for IQ is. We could look it up, but I just did 10, but that we would figure out every possible person to get that 10. That's why the 10 is such a big number, because it shows the difference between the scores. This is a normal curve. It's a bell shape. If you want to go 3 standard deviations away, it's just like 2 more %, right? But that's pretty much how it works. We're going to spend a lot of time on this when we get there. Hopefully I'm not overwhelm you with too much math, but I think it's time we just do the questions because the questions make it easy. So 6, 7, 12, 18. All right, let's start with number 6. Let's see what we got. And I said I do them by hand, or we can use Excel or StatCrunch. So let's just go right to number 6 before I give you way too much extra info. Yeah, I thought that would be the end. Cool. So let's go to number 6. We're skipping 1 through these. Here's number 6. We have this data. All right, number 6. So 20 through 29, 30 through 39, 40 through 49. Might just use Excel, so I don't have to actually do any of the math by hand. 60 through 69 and 70 through 79. So these are our ranges. In our case, they're ages where people won the best. Oh, God, that's ugly. People won the Best Actor award. And the frequency is how many people showed up. So we got 1, 29, 38, 16, 6, and 1. So let's see what the questions are for this. Identify the class width, the class midpoints, the class boundaries for the given frequency distribution. Also identify the number of individuals in the summary. It's real data from Appendix B. Okay, so we have to find the class width. Well, they did it for us. Isn't that sweet? So the class width, remember when I said width, it's just the max minus the min divided by n. But they did it for us. So our width is how many people are from 20 to 29. They're telling us, right? They already did these widths. It's in it. We can go to the chart and figure it out to do the formula, which I'd rather do the log one, but their width formula is the biggest minus the smallest divided by n, how many things you have. But we saw that it's not the best, so we're going to use logs. But theirs is from 70 to 79. How many numbers is that? 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's actually 10 numbers here because you got to count to 0. So we know our width is 10. That's the first answer. All right, let's see what else we got to do. The midpoints, the class midpoints, and the class boundaries for the frequency distribution. Kind of forgot those, so I'm gonna actually have to look back. It's okay. So we need the boundaries and the midpoints. So let's find them. We did the midpoints. The values in the middle of the classes. Table 2 has 7 class midpoints. Okay. So the midpoints are whatever's in the middle. So each class has midpoints of table 2-2 has midpoints of 7 because halfway between 0 and 14 is 7. Halfway between 15 and 29 is 14 numbers, so it's 7. So basically to get these midpoints, all you have to do is take the range and divide it by 2. So we're just going to take the width or the range of these numbers and divide it by 2. So our case is just 10 divided by 2. So our midpoint is the 5th number in the middle. So our midpoint is 5. Trying to see where they are. So if you get lost, so has 7 midpoints. So it's just all of them in the middle. So our midpoints are 21. So here they're saying it's the midpoint is halfway in the middle. So there were 7 of these. The first one they've got was 7, 22, 37, blah, blah, blah. So 0 to 14 is 7. Ours is 20 and 29. So the first one should be 24. Let's just make sure it's 24. If not 25. So we're going between 20, and I just want this to be really clear. So we're going between 20 and 29. What is the middlemost number? So So, and then I'll show you another way to find it. We have two numbers here. Our actual middle number is going to be 24.5. That's halfway in the middle. Why is that the case? I have 1, 2, 3, 4, 5 numbers on the left. 1, 2, 3, 4, 5 numbers on the right. So what is your middle? 24.5. Which to me, that makes the most sense. To find the midpoint, you just do n plus 1 divided by 2. We have how many numbers here? 10. What is 10 plus 1 divided by 2? Actual midpoint is 5.5, 5.5. So 11 divided by 2 is 5.5. So it's going to be the one that's actually halfway between. So a good way to think about where the midpoint is to just do your n plus 1 divided by 2, and this is going to give you exactly where that falls, 5.5. And that's the best way to think about it. So the total minus it divided by 2. So we have an equal number of values on both sides. So that's 24.5. This is going to be 34.5. This is going to be 44.5. This is going to be 54.5. This is going to be 64.5. And it's going to be 74.5. These are your midpoints for each one of these. All right, let's go to the next one. So for number 6, we got the width is 10. We got all the midpoints, which are 24.5, blah, 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 all these middle numbers. And now we need the class boundaries. Also identify the number of individuals included in the summary. Okay, that's fine. So how many people are in the summary? Well, we just have to add these up. So I'll do the summary before I'll do it order. So let's find out what class boundaries means, which I'm totally fine with. Class boundaries are the numbers used to separate the classes, but without gaps. 2-1 shows the boundaries of the gaps created by the class limits of 2.2. All right, so split the difference between them. So the lowest boundary is negative 0.5, and then it's just the number that's in the middle. Okay, so it's just kind of showing you what's halfway between these. We're starting at 20. So the first boundary for this one's going to be halfway between that. So your boundaries are what? Ooh, I do not need a keyboard. Well, maybe they were thinking I do. So for ours, the first one is we're going between 20 and 29. So the first one's going to be 19.5. It's just like a half less than that, because all of these are like singular numbers. So the next one is going to be 29.5. It's just like whatever's in the middle. They're telling you just to add up the two terms and divide it by 2. And it's just the same pattern below. So we're supposed to save this one for last, the highest one. That's okay. So we're going 39.5. It's just 10 every time. So 49.5, 59.5, 69.5, 79.5 is the last one. I believe that's the highest out of it. Yeah, cool. So it's just, this is a 1 number difference. So what's between it? It's a half. Awesome. All right. And then they just want the total values. So we just have to add all these up. So how many people do we have in this? Well, we can use a trusty calculator. 1 plus 29 plus 38 plus 16 plus 6 plus 1. What is our n here? We have 91 people. So they want the total number of people. The n for this group, they got 91 in it. Ta-da. Cool. So let's go to the next one. Let's see what other things we got to do here. So 2-1, we just knocked out number 6. It took a while, but that's okay. So we have to do 6. And the next one we're doing is 7. Let's see what 7 has us do. Oh, it's the same sort of thing. Okay. So here we go for 7. I'm just going to leave it on the side. So what do they want to know first? The first one they want to know is the width. What is the width of this thing? They did it for us. So the width is from 0 to 99. The width here is 100. It's 100 numbers. The next thing they want to know was the midpoints. All right, so let's get those midpoints. All you have to do is do n plus 1 divided by 2. So what is 100 plus 1 divided by 2? So we have 101 divided by 2. So our first one's going to be 55.5. That is our first midpoint. And then the rest of them is going to be, you just add 100 to it every time. 155.5, 255.5, 355.5, 455.5, 555.5, 655.5. We got our midpoints. All right, and then we have to do the next thing, which is the border and then the n. Okay, so the border. So the border for this thing. So between 99 and 100 is 199 divided by 2. It is well, I'll do 1. So it's 99 plus 100 divided by 2. What is 199 divided by 2? If you don't know, that's okay. Let the calculator do it for you. 199 divided by 2. 99.5. And doesn't that make sense? It's halfway between 99 and 100. So I'll just write them in. Oh, so the first one's going to be negative 0.5, 99.5, 199.5, 299.5, 399.5, 499.5, 599.5, 699.5. After you got the first one, and the pattern is just what? 100. Oh, sorry. The first one, which is this one, what is less than that? 99.5 minus 100 is negative 0.5, and 599 plus 100 is going to be 699.5. It's just the pattern. So these are all of your midpoints. Oh, sorry. These are all of your, I can't remember what they were called. They were called the borders. I don't know these little things had names, but guess what? We're all learning too for this. And the last one is your n or your total. So we just add them up. 90 plus 10 is 100. 151, 152, 153. All right. Hopefully we get one that's interesting. We did 6 and 7. And now we're going to do 12, 18, and 20. And I'll save the other 2 for you to do yourself. So let's go to 12. All right, 12. Normal distributions. Using a loose interpretation of the criteria where determining frequency is approximately normal, determine whether it is, and give you. All right, so blood platelet count of females refer to the distribution from exercise 8. All right, so let's look at this. Number 8. All right, so we can think about this. For it to be normal for 12, just remember it should be a bar shape. It should be equal. So if this is 100, They should all go up the same. It should be the biggest in the middle, and then they should match. They should be a mirror on both sides. So let's check this out. So the first one is 100 to 199. So this is 25. We go all the way up to 100. So basically, I'm going to make a little chart here. And I'm going to go 0 to 100. Then we got 25, 50, and 75. Our first one is 25. So here's our first box. Our second box is 92. Oh, well, I got to move the top. Get out of here. Okay. On this, I got to go to pencil. Sorry, I just wasn't being my friend for a second. There we go. So the second one is 200 to 299. Now we go all the way up to 90 something. The next group is going to be the threes, just so I have more space. So now this is the twos. Now for the threes, the 300s, I go back down to 28. The fours, I've got nothing, so it's flat. And the fives, I have 2. This is not right. This is what's called, I might as well teach you this. So it depends on the tail. So this is what this one looks like. This is what this is called. You name by the tail. So the tail here is on the right-hand side. So this is skewed right. So right skew. If the tail was in the front, right, and it like did this would be the tails here, so it's left skew. But we just want one that's symmetrical. Does this look symmetrical? No. The answer to this is no, it's not. Sorry, that's not symmetrical. It would look like this. The biggest would be in the 3, and they would match if it was symmetrical. It would totally match if it's symmetrical. So that is how you do number. So the biggest would be here. It would look like that. Oh no. All right, cool. So let's go to the next one. All right, so we did 12. Let's do 18 and 20. All right, let's go to 18. Data set. Refer to the data set 36 fast food and use the drive-through service times for Burger King drivers. Begin with the lower limit of 30 seconds and use a width of 40. All right, cool. So we got to make one. We got to find a data set. And we got to go from 30 and we're going in a width of 40. So it's going to be 30 to 70, I believe 71. Oh, sorry, for 40. So it's 30 through 69. $70 through, and then we got to add 40 to that. So it's going to be 109, and then it's going to be 110. So 149, and it's going to be 150 to 199. How do you make sure you're right? Is this 40? Boom. Is that 40? Yeah, boom. That's how I did it. To go by 40 every time. So these are our ranges. I gotta find this data set. So here we go. Fast food, refer to data set 36. Maybe it's in StatCrunch. We'll find this data set. Thought they would just give us one to use, but that's okay. Data sets. Perfect. So you go back to this one. We got a data set here. Believe it was data set 36. Oh, well, we got to download them. I'm going to download it as a zip file. Open it. 36, right? Fast food. Nice. Okay, I remembered it. It opens on Excel. And then you can copy and paste it into the online Excel. Sorry this video is taking so long. I guess there's just a lot of information for this one. Oh, because last time I did it on the web one, this one I'll use this one, but it's pretty similar. If you want to use it on the other one, you just copy and paste these, right? That's it. So let's see exactly what they wanted from us. And use the drive-through times of Burger King. Okay. Starting with 30 seconds and moving on. All right, I can do whatever you want. So here we go. We got Burger King. So this is the one we care about. So right away, I'm just going to delete these because we don't need them. So what's a good way to delete all this garbage we don't want? We're just going to cut them. Oops. Well, there should be delete columns. Nice. And was it lunch or dinner? We want Burger King dinner. So that's what we're gonna do. Burger King dinner. And we're just gonna make it happen. So Burger King dinner is not an order. So the best thing about this one, when I sort this one, oops, when I sort this, I could just, I don't have to expand it. I can literally just continue with this because I don't care about these. They're not linked like that other one was, which is nice. So I'm gonna delete this column. I'm gonna delete all these just so I have space to work in here. Nice. So, and I'll do all the parts. I know they just asked you for one. So I'm gonna do the range, or we can write BK dinner range. And we're gonna do frequency. We'll do relative frequency. We're gonna do cumulative. As usual, I try to make this easier to see for myself. So the first range, they said it was started at 30 to, I don't know, I think I already figured those out, but so 30 to 69. We got 70 to 109. We got 110 to 149. And then we got 150 to 199. Let's see if it goes further. I don't know how many are on here. Oh, we go to 293. Okay, so then we need another 40. So this is off. I made a mistake because I was about to basically do, because this goes up 40 every time. So this one has to be 190. So this has to be 189. Guess what? We're all human. We all make mistakes, right? If I made mistakes in here, call me out, send me an email. We're all human. So the next one's 190 to 40 more than this. So 189 plus 40. You could do them by hand on the side if you want. 189 plus 40 is a 9. It's a 2. It's 229. The next one is 230. And 229 plus 40 is 269. And the last one is 272. And if you want to do this yourself, 269 plus 40 309. I'm pretty sure this is as far as we have to go. So I'm gonna do a little box around this. Remember, if you want to use the web version, you can. I just thought I'd use the other one so you can see everything. No, I'll give it some more borders just for fun. Okay, cool. I'm just going to count. How many are between 30 and 69? There's only one here. We just have one. All right, it's from 70 to 109. We stop here. It says on the bottom of 6, or you can count 6. Next one's 110 to 149. Ah, 26, cool. 150 to 189. This is 7. It's not really symmetrical, but we can look at it more. The next one is 190 to 229. Oh, sorry, to 229, right? 190 to 229 is just 3. And we got 230 to 269, which is 6. So I can already tell this is symmetric. And the last one is going to be 270 to 309. It's just 1. So me personally, I would have done these by 50s. I think the 40s kind of make it look a little weird, but everybody's different, right? All right, so the relative frequency, what is this? This is your percentage, just remember that. So we need the total of this. So we can literally just click under here and hit sum, enter, we got 50. So the first one's 1 divided by 50. Gave me a date. Isn't that exciting? So I'm just gonna do equal sign 1 divided by the bottom. Enter. It's still giving me something weird, so I have to change this to be a number 0.2. Now, because I have the first one, I can drag them down. It's still giving me something weird, so I might have made a mistake. Oh, that's why. Okay, so we all make mistakes. We're just supposed to put the one number because this is a column, so it's not working out. So I actually have to just do divided by 50. Same value, but now when I drag it from plus to cross, I get them all. And let's say you actually want percentages, you hit the percent number. Ta-da, we add them all up, we should get 100% or a 1. Nice. And the cumulative frequency, just remember, it's the first one added down. So I do equals the first one. Enter. Now I'm going to do equals this one plus the next one. And I can drag it from the second column. And so there's 50, it matches, we're good. If you want to know like the actual range of this thing, we can do insert, column graph. See, look how weird, the histogram isn't true. It's so crazy, right? So we're going to delete this guy. I just want to show you it didn't work. So we do insert, not histogram, the columns, and there it is. Does this look like a bell curve? No, this would have to be the middle and they'd have to match. And because this is a downloaded version, everything's over here. So the element we want are the axes. So I'm just going to go to more options. I'm just going to put them together. It's not giving me a choice here. That's okay. I'm just going to double click them. Yeah, both. Now it's Instagram. What else would you do? Change the titles, all that jazz to make it look nice, but there it is. And I'll do maybe one more. And I will do 20. Unless it's the same thing. Yeah, I'll let you do 20 because it's the same thing. I want you to try that one yourself. So super long first video. It's like an hour. I'm going to do 2 more, but there's the first one. Hopefully that was helpful for you. I know it's kind of hard, kind of crazy, but I'll keep doing them. Let me know questions about it. Take care.